So today we are going to learn how to solve basic trigonometric equations with quadratics using substitution. So with this one, first of all, what you have to realize is that we're using both sine and cosine, and since one of the terms is squared, you're not going to be able to turn this into a proof statement. What you have to do first is substitute one of them. Now, the one I think that we should do first is cosine squared, because cosine squared, theta, is equal to 1 minus sine squared theta. So what we can use that for is we can substitute cosine squared theta in the problem with 1 minus sine squared theta. And the way that we do that is then by replacing it here and doing 2 times 1 minus sine squared theta plus 3 sine theta minus 3 equals 0. You then multiply by 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. Add the 2 and the 3, negative 2 sine squared theta plus 3 sine theta minus 1 equals 0. I'm just going to make that statement positive because it's sometimes a little bit easier that way. And from here, you can just work it like a basic quadratic, where you do 2 sine theta minus 1 times sine theta minus 1 equals 0. So one of these statements has to equal 0. So what you can then do is set each of them equal to 0. 2 sine theta equals 1 half. 2 sine squared theta minus 1 equals 0, or sine theta minus 1 equals 0. Then if you simplify these statements, sine of theta is either going to equal 1 over 2, or sine of theta is going to equal 1. And you're not done here yet, because you're not solving for sine of theta, you're solving for theta itself. So what you can then do here is, so 1 half is equal to either 30 degrees or 150 degrees. So those are your two solutions, and then for sine of theta equaling 1, that can only equal 90. So your final solution is going to be 30 degrees, 150 degrees, and 90 degrees.